All right. Thank you for the opportunity of sharing my experience of teaching a big data course. I'll give you a little bit background by myself. I joined Minnesota in 2014. That's when our MSB program gets started. And I developed two courses then, one on big data, the other on data management. Now I'm focusing solely on teaching big data. And also, I had a chance to be involved in teaching two big data modules in two executive courses that are new, and I also shared that experience a little bit. So in terms of, I also put some of my hobbies here. My point is, even though before that I had experience of like doing some crawling, doing some website building, but I did not really have big data experience. So some of you ask, how can we get people to teach big data? I can, if you have a new faculty you want to put on teaching the big data course, I'll be happy to share my experience how to gear up to teach that course. It might take a few trainings, and also, now there's more help. I think it's possible for us to take in charge of that course. So I guess there's still a question, I guess, whether it is essential for having big data in MSBA. I had some initial doubts, but now I'm more convinced that it is a very valuable component. You got this quote here. I don't need. So that's being popular. That's all you need to know.
So this should be your hobby, not that stuff.
Yes. Uh, uh, get a bit on more serious kind of tone is, so why do we need to teach big data? Or do we believe the organization is going to be using it? I think that in the process of teaching big data iterations in the last 3 years, my view on big data has transformed a little. That's kind of a summarize of my past. Initially, I'll be focusing more on size of data. Like, people start asking, what's the size of your data? Is it going to be big enough? It's more about taking a defensive position. Like, we have this challenge. We have too much data we cannot deal with. Can we use some big data tool? I think that's kind of maybe the first view, kind of literal view of taking the big data. But the next stage, you may be some geeks will get interested because there are new tools that can do different things, tools and capabilities. But really, I think that the realization comes that shows the big data is highly valuable is the other way of thinking about it. Big data may not be about size of data. Actually, it's about the big opportunity. Rather than think of big challenges, it's about big opportunities. I think that view actually brings me to the conclusion that actually big data is something that organizations should think about more, not less. There's also a sign that shows that big data actually is changing the way we are thinking about data. We're moving, for example, the industry is moving from data warehouses into data lakes. I think that's more than just a term change. That's the philosophical change. We used to think that we want data clean, organized, and put in a data warehouse. That's the way we want it to be. But the data lakes is about keeping the data in a pristine state and let everyone come in and to pick up the portion that they need, and that calls a different process, different tools. I think that's the change that actually that has happening because of big data. There's another one this is just for a joke. We're not taking that far yet. Maybe someone will. So I'll actually show this is how I like to kind of present or motivate the big data as big opportunities. I'll give you some examples. I'll quickly go through these. This is actually another way to kind of view in the 3 V's. Because when I taught the 3 V's, everyone knows 3 V's, 4 V's, 5 V's. But we actually don't ask the question why. So what this V stands for? Is this about what qualifies the big data, or is it actually about something different? So I think the way that makes sense to me is to present as opportunities, the big opportunities. Like the first one, for example, if in a healthcare setting, I would present, because of granularity of data is so much more now because of the digitization. Now we actually have this opportunity to leverage the data. You probably have heard the phrase that it's not about who has the best algorithm, it's about who has the most data or the best data. Right? So that brings out the point of these opportunities. I'll quickly go through this one. For example, variety of same ways. A lot of industry do not have the luxury of these Amazons, LinkedIn's, other companies who have all kinds of data with them. But these health companies, they do not have these. But how can we leverage data strategy is to leverage this unstructured data. So that brings up the value of using the variety. And same with the velocity is about real-time interventions, real-time monitoring, and so on. So I quickly go through this. So some of in the iteration of teaching this course, there are a few evidence to suggest actually big data is an interesting component, a valuable component. First of all, the students started telling me when they're looking for schools or programs to participate, they view big data as a differentiator. And at least at the time, that in the last 2 years, there are not many programs, MSP programs, that actually have a big data component. They were looking for it. So there are few that do have, they see as opportunity, as a differentiator. And then also the anecdotal evidence that actually people who took the course actually find a job. So they were saying they're specifically looking for a course like that, and they were able to use that to find a job. And they were saying none of the other courses were helped. This one actually alone create a job for them. The other thing is we actually have very crucial component in our programs called Carlson Analytics Lab. Basically a capstone, but it's would work with a real company for a semester. That one actually has been also another way for me to get feedback on, because we're started seeing more and more projects actually involve big data. And and I was part of the faculty advisor and going through this project. It was a learning experience for me, so the feedback loop for me. For example, last year we had this year we had two projects actually using big data. One doing the blockchain data and used to detect illicit transactions. One using cluster computing, find relevant patterns in the large pattern database. I think Eric was mentioning that this is a startup using the big data, and this is their business model basically. And previously we also had an IoT case where using AWS set up infrastructure to do real-time detection and predictive modeling. So these are actually were all pushing the boundaries, like pushing beyond the curriculum, and that gives confidence that actually they were a very valuable component. The other thing Robbie was mentioning is some of these companies like Walmart, like when they come to hire the data scientists or data analysts, actually they always ask questions about big data. So it's a big part of the interviews. I think that seems like indispensable to me. So that's where I kind of get this argument. And then how do I position the course? I think this part I don't need to spend too much. I have two goals on this. One is more kind of understanding, like understanding the opportunity challenges. Also from if you're one of these business person, like how can you understand, leverage, and lead the team in terms of using and leveraging this technology. So this is more like a higher level understanding. The other goal is actually do develop their core competence in using the big data tools and learn the big data processes, including many of the tools you will see here: Scoop, MapReduce, PakeHive, and Spark, and so on and so forth. So what this course I kind of not positioning it as, it's not a machine learning course. We have luxury of separate machine learning course that taught by other professors, so I don't need to spend time on. I'm assuming that they already know what these machine learning algorithms do, but let's utilize that in a big data environment, see how we apply it. And also, it's not about a big data administrator or developer course. So some of the kind of serious coding I purposefully avoid, because I think that this is not like the majority of the students are going. Is they are more about data science. They are applied these. They're not like heavy duty big data developers or system administrators. So that kind of separate some of the program from the computer science offerings of these courses. So in terms of the course, we have actually a semester-long course, 3 credits for 15 weeks. So we meet twice a week for 1 hour and 15 minutes. So I have the luxury of spending the entire semester on big data. So some of the topics, I start with Hadoop and ecosystem, Take and Hive. And also I do a little bit cloud computing. So prepare them for doing some this data science case. This is also actually got from Cloudera. It's kind of end-to-end data science using big data tools, starting from gathering data, analyzing the problem, gathering data until you have a product, and until even you can push it to the extent of testing the experiment, analyzing experiment data. So then the second half of the semester, I'll spend entirely on Spark, starting from the base Spark, and then Spark SQL, machine learning, and streaming, and talk about Spark application deployment. As you might have known, the Spark is kind of become eclipsing the Hadoop. It become the most popular big data framework. The Spark developers are more than all the developers combined for all the other big data platform products. So it's been and students love it because Cassandra is more like a specialized product, NoSQL database. So there's kind of it's part of the component, I would say. Like we also have HBase and other NoSQL database, but this is more like a Cassandra more on the storage side, whereas Spark is more on the computing side. So I think, but Cassandra is also I believe it's Amazon's NoSQL database. We do spend some time on HBase, and they're similar. So this course has involved so much, like half of the course. I started out with just the first half. That was the entire course. But now the first half condensed half of the semester. Like we added the entire Spark component to the course. And I can assure you, in another 2 years, you'll see another at least half of the content will be new, because the field has evolved so much, still evolving very quickly. So we do have, we actually have 2 exams, midterm, and also a team project presentation towards the end. I'll talk about some of the topics specifics. I think I already kind of mentioned some of these. These are constantly changing. Each semester I'll do some major update. And I did not spend time on writing Java-based MapReduce applications, and I think that's for developers. We did not spend much time on installing and configuring big data environments. I think that's what it's not for the data analyst to focus on. I do give a lot of importance to products such as Hive and Spark. I think those are bread and butters. Like Hive, you may think of data organization, data engineering. Spark it's nice in the sense that kind of have a full spectrum of functional modules, from data processing to advanced machine learning and streaming processing. So that leads to some great applications of big data. So that's where we spend most of our time on. And there's this interesting choice when you teach Spark is whether we should teach in Python and Scala. And that's an interesting one for MSBA because the trade-off is Python. The students are already familiar; they're easy to get into. The downside is if they are to look for examples online, many of these are going to be in Scala. So the Python is still lacking a bit behind in terms of the implemented functionalities. So I've gone with Python, but actually some students I request to also include Spark. For what reasons? Actually, they have seen a report. If you know Scala, your salary is going to be 10K bump, something like that. So yes, and so we do actually provide for each homework assignment examples. We actually provide a Scala parallel, so that for students, I even give them bonus credit if you can do it in Scala. So that's so far my way of doing it. There are plenty of areas for further improvement. I think after listening to Eric's talk, I think I need to revamp this list still. But there's certainly, based on the experience with the project, I think teaching them just the basics is not enough, because scaling is hard. Like scaling the STEAM analysis for big data skills is hard. So certainly we'll be spending more time on, for example, how to optimize the Hive queries, choose the right data formats and choose the right ways of partitioning so that you get more job done in less time. And there are also, I think these are high-end applications like streaming and NoSQL, graph analytics. They are actually quite useful. So I think I want to spend more time on those as well. I think this part will be useful. I think so right now, I think the formula for us is to. So there's a good question: how do we set up an infrastructure? I think most of the B schools may not have that resources or capabilities of providing like private cloud. the way we've been doing is, so we use the virtual machines. They are set up like pseudo clusters. They can be installed on their laptops. The requirements, they have 8 gigabytes of memory, so it ensures smooth. They have analyze small data sets, but the process and interfaces and like fields will be more like big data. So it operates on CentOS, it's a Linux, a flavor of Linux environment. So they will be operating in that environment. So actually, we spend a good part of the semester on this environment, within this environment. And then we'll also teach the AWS cloud computing and also have projects. The goal there is to scale up then, is that the project and also the AWS teaching part will require them to have, so we'll have apply for AWS education grant each year. Students get $75 for free, and they can use that money to spend towards their computing expense on AWS. I think Azure also have similar deal, like you can also apply for credits. And so we have tutorials set things up, and so they can run pretty much run the same things that you learn from the tiny virtual machines and run actually on a real cluster. The interesting thing is that there are also some third-party vendors. They simplify the managing of cloud resources. I think we're exploring that as well. I most likely incorporate one of those in the teaching. One's Databricks, the other one's called Kubo, and so they allow you to manage the cluster in their interface without having to get into too much details in setting up the Amazon space. So I think my experience has been pretty good using these third-party vendors. Briefly about prerequisites, this course has several prerequisites. I think some of them are more essential than others. SQL is absolutely essential, so I would require that. And the other thing is machine learning algorithms. They better know some machine learning towards the end in order to select and choose and use. But I will not spend much time on those. And then the other thing is this course will be more Python focused. Although I think along the, in the future iterations, I think I will certainly also explore R, Spark, like as a tool, so that they can combine that with their favorite R packages. Then some degree of operating system knowledge is helpful because in good part of the course we'll spend in a command line environment, which some students struggle. So I think I have a little Premiere to set up so that they can give them the basics of working with the command lines at the beginning. And this tends to be the problem, the Python and the command lines. So there are a few things I do specifically for this course that has worked well for me, or at least what I thought. The one is at the very beginning, I'll tell this is a course very dynamic. I don't have answers to all your problems, and we probably always encounter some bugs, some issues. Yes? Oh, okay. All right, so. All right, yeah. One of the things that worked for us well, I think you probably have already heard from Minnesota faculty a couple of times. We use this Yellow Dig, which is a Facebook style forum, and I integrate that part of the curriculum. And it's been very successful because students share the knowledge they find on the internet and they respond to each other. And me and TAs, we will also come in, frequently interact with them. And they also ask questions either related to homework or related to things that have been encountered. That's been actually very helpful. And after the license expired, so this is, unfortunately, it's a paid service. And we're thinking about moving to Slack. I think Ravi was mentioning, because I also find Slack to be a very dynamic, very good channel. I think that's something I'll move to. So this gives you a sense of what Yellow Dig is like. And this is actually student posting things, other students are responding to it. You know, each semester I got some ideas got some good resources from their contributions, and that can be integrated to the next iteration of the course. So the other thing is about, I designed it to be a very hands-on course. So there are about 23 lab notes, I counted some, and all of the lab notes have solutions. what turns out to, how do I manage this? I thought about this, how do you do the labs? So eventually what I do is I do lectures in class, some demos. All the labs are, they do it on their own. I integrate the labs with the assignments, so that assignments will be closely follow the labs. They sometimes even use the same data set, but I kind of model after that. The idea is they want to do the assignments, they need to go through the labs. It's better for them to go through the labs. That gives them incentive to go through the labs, learn through it. And then I have 8 assignments that are, so this is kind of a style assignment. I have some conceptual questions at the beginning, and then have some hands-ons with some data sets. Ask them to turn in their commands, scripts, and the results, and then we'll grade on them. And the other thing that also helps is for record some short videos, like demos. We don't have all the demonstration in class, but we have record short videos so they can watch it whenever they want to share with the students. The other components, team product design. This is also the part that I like. Is we designed to be a kind of on the edge team projects. So you encourage them to be innovative. So they can innovate in one of the 2 ways. They can choose the topic that we haven't explored. For example, one team explores Storm and real-time Twitter Storm applications. So that's something that they could do. The other one's kind of using to do a problem solving, like using the tools we have learned, do the problem solving, work with the real world data to demonstrate that you can do at scalable. The key word here is scalability. So we want them to be able to scale up. I think if you can handle, a few million rows or maybe 5 gigabytes data, I think that's good. Like you can scale up. So I think the other thing I was thinking in the future project is the other thing actually I was thinking that if we have the room in the class is to design a project where everyone wants the same giant data set, and let's compete on like scale the performance, timed completion, or all the calculation performance. So that could be another product design. So everyone really push them on the front of scalability. So whether they can handle it, whether they can do things more efficiently. So some of the project sample topics in the last offering, you can see some of these involve streaming, some machine learning, and some text analytics. Some of the Reddit comments awesome to use big data tools. So that's been. Okay. 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 I see. All right, I'll talk to you more about it. I'll spend a little time to a few minutes. Anyway, I don't have a lot to talk about here. So executive audience, I've tried 2 opportunities to do that. One is really open enrollment exec program, and there we get a variety of different people. In fact, we did not know what we will get until we start the program. So their at least initial designs, we wanted to have some hands-on component, and so one, other than demystifying the machine learning and big data, we also want them to kind of experience it. So I used like a Jupyter notebook kind of style and give them some sample program. They can push the button to run, and they can modify it. Guess what? That did not work with them. I think they did not. They think it's too much. The main reason is many of them think they are not going to be the doers. Like these are I think that this is not my job. I hire someone to do this. Can you show me something that that something has to do with my job? I think that's the main reason. It's not so. I think the second time I do, since of course this program is for a big health analytics company, and they want their directors to be trained in machine learning, so they want to be case-based. So I did more this time, no hands-on at all, focusing more on the use cases. And most student RT directors. I think this time it worked better, a lot better than last time. There's still lots of room for improvement, but I think it worked a lot better. So in terms of, so I think I already talked about these slides. At least I got them to discuss, like to be engaged in discussion in terms of what's the implications for their organization, like in terms of architecture, infrastructure, also the kind of problem that they can solve. So kind of the organization of that, it's only 2 hours. I didn't get to go through a whole lot. So I started talking about, getting this into thinking, let's talk about big data. A lot of people say, my data is not big, why is it still relevant? I basically go through the exercise where kind of turning from thinking of more defensive thinking into a kind of opportunity, taking big data as opportunities, and then give them many use cases in the healthcare industry. That's where they actually start talking a lot. Like, they start related to their own practices, their own challenges. They also, I think, also need to spend some time introducing Hadoop MapReduce and ecosystems and Spark. The idea is more demystifying, and also and use a use case. I don't think I have an opportunity to do the use case. So I'll just jump to the future thoughts on this one. I think again, the priority should be give them higher level understanding without actually practicing, without actually doing it. Get into the details of doing it, but they should have high level understanding. I think the other use cases are actually it should be a good instrument to teach these audience. For use cases, I think some of the things that we should focus on is problem formulation. I didn't get a chance to explain that use case. How do you formulate the problem as analytics problem? Where do you find the data? Is data going to be enough? Like, if the data is not enough, what can you do, right? So some of these things, and if you're dealing with data, what are the tools you should use? What kind of algorithm should be used? What kind of architecture? And in the end, like, how do you evaluate? What are the challenges and risks? I think these kind of, if we have a use case like this is the right kind of the materials to teach this audience. Gordon and I were starting a Slack channel for we haven't opened it up for people who want to teach big data. I see a lot of programs starting having these to kind of collaborate on sharing materials, share strategies, sharing best practices. I think be sure to talk to us. All right, yeah, so be integrated into that platform. Great.
Yeah, there are so many things, new things you have to figure out to develop such a plan. And there's a few things how much time you have to spend to make it happen.
So my primary develop.
So let me see. Yeah, there are so many new things. You have to figure out to develop such a plan. So I just want to know how much time you have to spend to make it happen.
So first of all, I don't do all at once. Like it's more about prioritize. And the thing is, I think I do a lot of judgment in terms of what to emphasize on, and do it step by step. Like, I think I primarily spend the summertime to develop these new function modules and so on.
Once you get the infrastructure set up, the actual technology is pretty intuitive. Like Pig, Hive, and Spark, they're all kind of intuitively, you can draw from your SQL and other knowledge and move it forward. It's not that hard to do once you do it. If I can as a full-time administrator
Yes, it does. I think that's where the collaboration is useful, and also the iterations. Like someone who teach now can kind of get some materials from us, and then can start building on those. And the other things, because we get from the projects, and also from student project, and also the Carlson Analytics projects, actually some of the materials can be used towards future development. Yes, I have to pick and choose. I cannot cover all the grounds. I think the other strategy is, as I already explained, to have the open channel for students to share their ideas, use their project as a way of expanding what I teach. So that's very important. I like to keep that way. Kind of using a team project is more of kind of expansion opportunity.
Thank you very much.